next speaker is on the cutting edge of simulation and visualization on collisions for automobiles. And as much fun as that sounds, it's been a painstaking process to, over the many years, to be able to capture all of that data and reframe it one baby step at a time so that comes out of the computer what would actually come from a real test, such that we can get to the place where the results from the simulation are accepted in and of themselves, and we can do fewer crash tests, saving time, saving money. Seeing what others haven't seen yet and getting to the future first is what Bill Taylor said yesterday, and that's what Eric Hoff from Honda does for a living. So let's get Eric out here to take you through some fascinating stories and some amazing eye candy. You guys are going to love some of the visualizations that you get to look at next. So, ladies and gentlemen, Eric Hoff from Honda.
Thank you. Tough act to follow, I'll tell you. Right before lunch and the human heart. I'm Eric D. Hoff. I'm the technical leader of CE in the Vehicle Crash Safety Group at Honda R&D Americas. And my primary responsibility is developing methods to simulate car crashes. So, Honda R&D in the cornfields of Ohio is an R&D center. We have about 2,000 associates. We develop North American and global vehicles. You can see pictures of them over there. And we are on our third generation of developing the light truck platform for North America and the rest of the world. So on our campus is this state-of-the-art crash facility. We have a 100-ton movable block, so we don't have to switch bears. We just lift the block up, turn it around. And you can see our pitching sled here where we do a lot of restraint testing, seat belts, airbags, and we don't have to crash a full vehicle. Honda strives to be a safety leader, and we're doing really good. As you can see by our IHS results, we currently own the top spot for the most vehicles, getting the top safety pick ranking. And we just added the Accurate TLX last week to this list. So how do we become a safety leader? There's a couple things I want to talk about. One is advanced safety structures. Normally when you develop a vehicle, you have a couple longitudinal members that absorb a lot of energy. Actually, those pictures are reversed. On the left is our advanced compatibility engineered body, which we developed clear back in 2005. And what it does is it dissipates the energy in the front engine compartment to more members and leads to less energy going into the cabin. We've also developed a continuous ring concept for the cabin made out of advanced high-strength steel. It's one continuous piece, and it reinforces the cabin area to protect the occupant. So one of the big innovations that we've used in the last few years is steel. Lots of advanced high-strength steel innovations have happened, and in the MDX, we actually have almost 60% advanced high-strength steel, which allows us to save 100 pounds out of the previous version. So the next thing that I'm going to talk about is CE capability. We use CE a lot to predict what's going to happen in the tests, and this leads to shorter lead times and quicker to market. We do body stiffness, noise and vibration. We use CE for spot weld fatigue life. We predict the fatigue life of every spot weld in the car, which is about 5,000 of them. We do suspension strength CE, and of course, my realm, which is the crash. So what goes into a crash model? Actually, we start with CATIA. The designers put a digital prototype model together. All the data goes in there. We roughly use about 80% of the parts in our crash models. We build one model for all modes and share it so it leads to consistency. And you can see kind of on the right what goes in. About 4,000 parts, 5,000 spot welds, all the bolts, the fuel lines, the electrical lines, the battery, the seats. We actually even put fuel in the fuel tank. Also in this, to get real accurate predictive CE, we include material fracture. So we're getting down to the real nitty-gritty of the model. We can predict fracture in a part. We also predict spot weld failure, which leads to a lot of problems, as you can see in there. This model is solved using LS-Dyna, which is a very high-end nonlinear explicit finite element code. And then this next video is going to show you what the results look like in a normal or post-processor. Hopefully. So this is what a CA expert looks at every day. And if you've looked at them long enough, I mean, this is a great tool. I mean, you can see a lot of deformation. You can see what's happening in it, but, you know, really flat in color. It's painted many, many different colors for each part. But from a CA expert, that's fine. From a non-expert, it looks a little cartoonish and a little made up. So let's go into how we develop a vehicle. Past developments, again, we made a lot of clay. We scan the clay, we turn it into data. We do a little CE, but we built a lot of prototype vehicles. As many as 60 plus cars. We took 3 to 4 months to test them. You have problems, you run out of cars, you can't fix them. So, you know, it gets very expensive and time consuming. And then finally, after we went through that round, we'd finally test them again on mass production tools. So Honda and a lot of other car OEMs are going to a virtual development process. Again, we start with some scanned and some clay, and we scan those into 3D digital data. The designers take it, put it together in a feasible design. We still build a few prototypes early for driving, because it's still hard to simulate the person sitting in the car and feeling. But now we do lots of CE and virtual testing. Working with the design groups, we do 3 to 4 major loops of this process. And once we're done with that, we actually give mass production go tooling based on CE results. We don't make the prototype parts anymore. Finally, once those mass production tools are gone, we build the cars, and we do confirm every vehicle test once, at least once, at the end. So the success of this process is obviously based on confidence in these predictive CE methods. So how do I get the confidence from my non-experts? Let's go to another story. 2014 MDX, small overlap test. It's a test that the IHS, Insurance Institute for Highway Safety, started about a year ago. It's to simulate either just barely clipping an oncoming car or driving off the road and hitting a pole, not in the middle of the car. So it's a 25% overlap at 40 miles per hour. And you can see on the bottom picture, it just barely misses the main structural members. So there's not a lot of structure out there to absorb energy. So it's a very violent test. We do measure occupant injury plus some structural ratings. This next video is going to show the actual test at the IHS. So as you can see, it's very violent. Not a lot of structure is held. You can see it peels back and hits the cabin. There's many views here. See the wheel shatter, the chassis shatters, and there's not a lot of structure out there to absorb all this energy. This one you can see what happens to the occupant inside the car. Airbags help protect. It's a little different mode with the occupant because he kind of goes at an angle with the offset. Here's a front view. So you can imagine that's pretty hard to simulate and get it done accurately, but we've actually done a pretty good job. So again, as we saw before in that other video, this is what our experts look like at every day. I mean, you can still see the deformation, and it looks kind of like that video. But when you go to a non-expert and try to explain these results, they say, yeah, I kind of believe you. I mean, it looks cool, but I'm not sure if that's real. So, you know, my ultimate goal as a CE engineer is to accurately predict what's going to happen in the physical world, but it'd be great if those results looked real when I show them to non-experts. So, working with 3DEXCITE, you see my model there, but we went from that, and in 6 months, we went to this. And this is the exact same data set. Nothing's changed. All we did was add the correct lighting and rendering to that model. And then another thing is from this to this. So as you can imagine, if you're not a CE expert and you look at this, I'm hoping all you say is, I see a crashed car, not a model. That's my ultimate goal. So we did this about 5 years ago with an in-house rendering expert, and it took him 6 weeks to do one scene. Now with the 3DEXCITE and the Real Impact plugin, I can do it. I'm not a rendering expert at all. I can do it in about 2 days. So that's a huge time savings, obviously, and a huge plus. And if I can do it, it's got to be pretty easy. So this next video is going to show you the comparison of actual on the left, reels on the right. Sorry, reels on the left, actually, models on the right. You notice the same 3 guys will be watching both the model at the top. So it's kind of cool. You can put it in a real setting. You can use the real background of the lab. We'll use our test lab to put in the background when we run our models. So that's what it looks like. So, thank you. So again, it's not just making pretty pictures, it's an engineering tool. So we can actually, with the DeltaGen software, we can hide parts, make them transparent, and really dig down as an engineering tool into the structure. So this next video will show you some of that, those options. So now you can take off the outside and you can see the major structural members, what happens when the wheel and the brake caliper and everything hit the door and how the door deforms. So you get all kinds of good views, and this is, again, when you're talking to the body engineering guys, this is what they want to see. When you talk to the chassis guys, they want to just see the chassis. Everybody just likes their parts. We like the whole car, but they just like to see their parts. So you can change colors and see, now you see where where you're absorbing the energy. You can see the material tearing. So really powerful tool to make views. So when we started this, I said, I need to make it familiar to our crash engineers because I don't want them to learn anything new. They got enough to do. So when we did this, we actually read in the LS-Dyna results, and all the groups and the setup of the models actually populated into the DeltaGen software. So when a crash engineer puts in his groups of tires and body and everything, it comes right into the DeltaGen software, and it's familiar to them. And so, easy to click on and hide and view parts. So the module is called Real Impact. It's a plug-in to the DeltaGen software. We use all the features of the DeltaGen. You can render results in real time, be interactive, or you can do it offline and get the really cool videos. And again, it had to be the easy button. I couldn't have anything too complicated to learn. So some of the challenges from the DeltaGen side was there's no real easy path from the LS-Dyna results to DeltaGen. Used to using CAD. CAD's just a bunch of surfaces. Now with the crash model, it's not just a surface, the wheel's solid. And when it breaks, I don't want to see it hollow. It's actually solid. So now you got to work with all the surfaces and everything inside as it breaks. So that was a big challenge. The other big challenge was just the data size. Again, they're used to rendering one car sitting in space. Now you have 100 of them. A whole full crash event takes 100 to 150 milliseconds. We put out data every 1 to 2 milliseconds. So you can imagine, now you have 100 separate cars that have to be rendered. So it's a really big data set. So going to show another video here of the real-time interactive part. So here it is. This was in the software. So this is the type of rendering you get when you just load the model in. So you can load several of the states in, and you can spin the model. You can look at every view. You can step through each state, break it down at certain times. You can do really good views. You can isolate the components. Like this one's going to isolate the chassis and just show what happens with to the chassis during the event. You can step through it. And you can see we're picking the groups on the side, which are just what we do in the crash model. So they're highlighting all the chassis parts, add them on there, and now they'll step through and show what happens to the chassis. See the wheel and everything break. So you can go in, obviously, and change colors, highlight more parts by different colors and shading. So here we're isolating the body, the critical body parts. Turn it around, look down, all kinds of views. So this is the real interactive part and the real good engineering. So we sit down with body designers. We can break down what their part does through the event. And if we need it to buckle later, we'll make some changes to that part and make it buckle later. You can do some exploded views. So a really powerful tool. So you can also do offline batch rendering to get the really nice videos. There's a custom batch render panel made. And ultimately what we'll do is we'll send this to our high performance cluster and maybe render a few scenes overnight. I believe I have another video of the offline. So this is the kind of videos you can get when you go offline. And actually there was a lot of artists that had a hand in this. This is a really good view. So you can hide the walls and see really what happens. Highlight all the skin and see what the structural members are doing. Again, in a realistic scene. This is a side impact model. So you can do the slow it down and for artistic effects or even engineering effects. Hide the roof, see inside what's happening to the occupant. Up close views. So from an expert's point of view, you can see a lot more with this kind of rendering. So another great feature of this software is you can actually place onboard cameras. In other post-processors, you just kind of zoom in and try to track certain points. You just can't get a good view. But with this, you can actually put cameras in any location you want and track them. And this next video shows that too. So the first one is an off-board camera, which is typical for our crash tests. The next scene will be a mounted on the door camera. So we can put camera positions exactly where we put them on the test car and match them up and compare exactly to what happens. These are similar to what we'd have in a crash test. And this is a really cool view. You can x-ray the dummy and see what happens to the dummy inside. Now you're riding in the front seat of the offset car. So, and it didn't hurt, right? So you can get some really good novel views with this. And again, this can be done in 3D stereoscopic. And ultimately, I think I'm going to put people in the car during the simulation so they can see actually what happens and experience the dummy's point of view. As you showed the x-ray and exploded views. But anyway, some really cool novel views can come out of this software. So why do we need this? Mainly, it's a great communication tool. As I said, experts know what they're looking at every day, but when I go to non-experts, executives, they like to see the real thing, and they are used to seeing test results, so physical test results. So I want them to make it look like the physical test results. So anyways, I want to give a big thanks to Tom Selesnak, who actually developed the plugin. He was the genius that wrote the software, and Tim Ventura, who actually hooked me up with Tom to put us together to make this happen. So if you have any more questions, you can hit the 3DEXCITE booth out there in the playground. Be happy to answer any questions. Thank you.